project is about a gimbal, that is a robot able to keep a video stabilized during motion. Despite the coronavirus outbreak, we were able to meet all together and complete the project in about 1 week.
I am here to show you the kinematic model of the gimbal. The gimbal is shown in the video and is an example of spherical wrist. In fact, the three axes of motion of the joints are perpendicular and cross at each other in the camera lens. It is for this reason that the recorded videos don't translate when the joints are actuated. The goal of direct kinematics is to express the pose of the camera with respect to fixed base reference frame. To reach this purpose, we have to apply the DH convention. The DH convention is a systematic procedure that leads to obtain the transformation matrix T, crossing from the DH parameters that is shown in the table. Thanks to Peter Kolb Toolbox, we can simulate the kinematics model that we have obtained before. As we can see, the task space is spherical, and we can orient the camera, so then the effector reference frame that you can see in this moment, changing the values of the joints variable Q.
The 3D modulation part was made on Fusion 360. We modelized the free links and a comfortable grip, able to keep the full stabilizer with just one hand. On the right side of the grip there is an extension that we decided to put there for keep the cables and the board away from the rotation part of the robot.
This is the Arduino IDE, which is the platform where we write our code. We start including all the libraries we need, so one for the servos, then the I2C and the wire.h for the I2C communication between the board and our gyroscope, and finally the MPU6050, which is a specific library for our sensor. Then we name all the hardware parts that are included in our project, and we define the pins at which they are attached. Then we initialize all the variables that are needed to run the code, and we go into the setup function. In the setup function we initialize the MPU6050 and we check if everything is working well. In a positive case we go into the loop section where we read the Euler's angles and we move the servos accordingly.